Yeah, Rich will be here.
You want me to go ahead and get started or wait?
Nope, give us 2 minutes. We're trying to get Richard into our live meeting here, and also Chris online. Just give me a couple minutes.
And
Sorry.
Not a problem.
Just to make it official, we are recording at this time.
Okay, good. Yeah, a lot of this, I'm sure we'll end up going back over if we have questions. Having it part of the archive will help a lot. Thank you.
No problem.
Yeah.
Call Chris Robinson mobile.
You have 2 phone numbers for calling Chris Robinson mobile.
Hey, I sent you the phone number and the PIN. I know it's hard to do while you're driving. Did you get it? Texted it to you.
Over.
You there?
I never take calls when I'm driving.
I think I lost. I think he's pulling over. There's no service. Is that normal here?
Mm-hmm.
If anything can go wrong, it will, right?
Yep. Well, actually, I got really low bars today.
Yeah, mine actually says no service.
Got 2 bars, but they haven't got 10 right up in the next building by the fire, right?
How you doing?
Oh, just marvelous.
We're being paid.
Yeah, I've got this on record, so let me get, I'm just trying to get Chris Robinson on the phone, but unfortunately I've got like no service. I don't know if I can go stand outside.
Who's service?
You're special.
I got one bar.
I have 2 bars.
Did you take the tower in?
I don't know. It's unusual. 2 bars.
I got 2.
I have 2 right now.
That's surprised on it. That's just great.
Oh, now I got 3 bars.
Doesn't like
That's normal.
dealing with that.
This microwatts do wonderful things, don't they? And can you guys see my screen at this point?
Yep. Whole bunch of pretty colors.
Okay. Okay. Good.
Just locked himself out.
Oh, yeah. Oh, he went out in the lobby.
But that phone number isn't working many times.
Really?
Yeah. Let me check it and make sure it's not my fat fingers or something. Did you have 616-749?
646.
646.
749 3129.
It's 646-749-3129. Yep. 646 instead of 616. That's my fault. And then the PIN is 576-939-3-485. Okay. Sorry, Chris. All right. Okay, he should be on now. Okay. Wait for Chris to join, and we can start.
Okay.
Hello.
Hey, Chris.
Okay.
Okay, good. Lynn, you're on. This is Chris Robinson.
Okay.
He's our Director of Engineering at Reliabotics.
How are you doing,
Hey,
Chris?
Lynn. I'm
Lynn,
doing well.
Chris Lynn.
Yourself?
Good, good. Hey, thanks, guys,
Okay.
for pulling this all together. And hopefully I can describe what we need and what we have and what works and what we can do and what I need you to do. So
Very good.
I'm guessing that most of you have seen the product, which is what I have on my screen right here. And this is the silicon sensor with the platinum bond pads. And that is 220 microns wide across there. The 48 gauge wire is 32 microns in diameter. So we have the trifilar wire that we need to laser strip, cut, bond, and then encapsulate that with the epoxy. And then, of course, cure the epoxy. After bonding to the sensor, before we do the epoxy apply, we need to do a cleaning operation. And the best that I've come up with so far, and I still have research to do, is to take a laser and just lightly clean the area that's going to be bonded. Occasionally, there's some organics that get on this part. I've tried different cleaning methods, but it is so small that obviously if we use any liquid, that becomes a problem because you have to make sure that you get rid of that liquid before you put the epoxy on. It is a polyurethane 180 insulation on the wires. And this is about 3/4 of a millimeter long. It is 0.003 of an inch thick, or 70 microns. Now, if I go to the wire itself, if you can imagine that a wire is being paid off on the right side, it comes from a spool, goes through my tooling, which I will show you. And then in the laser stripping and cutting area, it's held and secured on the right side and on the left side. And this portion spans across the laser working area. So from the bottom and the top, I strip that wire. And this is somewhat optional, but currently what I do is I strip the 10 millimeters. And then I cut the wire, and then I come back and strip this 0.2 millimeters or 200 microns of wire. The reason I do that is it tends to keep this more clean rather than stripping the whole thing and then doing the cutting. If I do that, it tends to have a little bit more debris on that wire. On the outgoing side, what I do is I have a spool that I wind the outgoing product. So as you can see, you'll see a carrier here in a little bit. And what that is, I'm holding this end of the wire very close so I can bond the sensor here. The rest of that, which may be anywhere from maybe 0.6 meters to 3 meters long, is wound on a spool. This is my current carrier. So as you saw, I was pulling that wire through here. I wind it on this spool X number of times to get the right length. And then I hold that wire in position. Here you can see the wire and the sensor. Obviously, I only have the wire and it's not flattened in this condition before I bond it to the sensor. My current tooling I have a flipper on the top that I close, but let me change the transparency here, and you can see that I have a ported area, and I'm pulling vacuum, which holds that wire down. Now, the wire is obviously a lot longer than what I have shown here. What I'm currently doing is on this area here, I have ported argon gas. So once I strip this end, it is encapsulated with argon before I bond it to that sensor. Now, let me go to the system, and I'll show you our current system now. I think maybe some or all have seen the video that Steve has taken when he was here. Now, our current system consists of the laser, and I show the carrier in multiple locations. We actually have 2 carriers. I have an umbilical cord that hangs from the top, and that carries vacuum and argon to each of the 2 carriers. I have my laser station here. Let me bring up my despooling method. This is my supply spool here. Now, I'm currently in the process, wait a minute, I don't have, let me back out here. Don't have that. Steve, this is a little bit different than what you saw. And
yeah, a little bit.
What we currently do, we pay off the material, go through this V-shaped spool, and that is positioned down in line with this unit right here. The operator is responsible to flip those lids open, carry that wire through, close the lids, and there's vacuum that holds it in that channel, and then pull it to a given point, secure it to the spool, and then the spool winds X number of times depending on how we have it programmed to get the right length. What I have in the works is, and let me change my view for just a minute. Makes it a little clearer. Okay, what I have here is I'm paying off my spool, I'm coming around here, and then I have a pinch roller and an encoder wheel. So what I'm going to do in the future is measure my incoming material to this process rather than the outgoing material. So once I secure it to that spool, I'll still wrap my right number of turns, but I'm actually measuring the incoming material, so it's not dependent on the operator pulling it to a given point and securing it to that spool. That's a minor change, but that's just something that we have in the works. And I think that's going to be a much better approach in the future. Here I simply have a wire guide that tends to guide it as I open this lid, manually grab that wire and pull it through. Now, one of the things I want to talk about when we get into the automated system, right now, like I mentioned, the operator is picking up that wire, carrying it through, and securing it to that spool. I'm quite optimistic, but I'm open to whatever you guys think too, to use a robot to pick that up. And keep in mind, these carriers can certainly change in configuration. This spool could be above or below this incoming wire. It could be positioned vertical. So just keep in mind there's other design options as we go to the automated system. But I think that we could use a robot to pull that wire. The one thing I'm not as confident of, and I hope we can maybe work through an automated way to apply tape. Currently, our customer prefers taping the wire to that spool. It then wraps up, and then once we're done, we end up taping the other end to the spool as well, and we ship the spool and the product to our customer.
Do you need that thrown into a bag as the final process? Because I know you said you would maybe like to incorporate tests at a later date.
I would like to incorporate testing at a later date, and let's talk about that as we get into the automated system as well.
Okay. All right.
Currently, we're taking it off here, going through an offline check, and we're doing that resistance check offline. So that's my laser stripping method, and I have the wire then wrapped on the spool and extending a short amount off to the right end of this carrier. While that's occurring, this is an air vac system. I don't know if you guys are familiar with the brand air vac. And we bought that as a demo unit, and it included I don't have all the details shown in this view, but it included the pick and place unit and the epoxy dispense unit. I have added this tooling, and what we're doing at this point is picking and placing, or picking from a gel pack. Each gel pack has 100 parts on it, and that is different than what we're going to do on the automated system. The automated system needs to have a wafer feeder and will feed directly from the wafer. Currently, our customer is picking from the wafer, doing inspection on these parts, and then shipping the parts to us on that gel pack. I take one part at a time from that gel pack and put it into this movable fixture block for my sensor. So this portion here, I moved between the pick and place unit. I actually have two of those. Let me back out here a minute. And over here in the bonding station, I have another one of those. So I'm bonding a part here while I'm loading a new sensor to the fixture block here. And this fixture block is simply, it's a machined piece of aluminum. This piece here that is shown transparent is a 20 thousandths gauge block. I then have laser drilled a hole through that 20 thousandths gauge block. That is in turn open to a pocket in the aluminum to draw vacuum. You can see that I have a small vacuum hole that's pulling that sensor down. That's about a 6 thou hole. So imagine the wire is not there. I simply have the sensor now in this pocket. What I have on top of that gauge block is a 2 thousandths piece of shim stock. I have laser machined the opening in that, so it's a slip fit for that sensor to drop it in that opening. It doesn't need to be absolutely exact, it just needs to hold it in position. In turn, I just simply have a hole down on the top of that, another piece of shim stock, and then I have it all encapsulated in that block. Keep in mind that as we move toward the automated system, the physical outside dimensions can all change. I think this works quite well. And keep in mind too that we have worked enough with this. I know what works. I know what we can do. I think it all makes sense if we provide the part contact tooling, or we can talk about that. So this is picking and placing a sensor in that location while I'm doing my laser stripping. Let me move over here to the bonding area. And what you see here, all of these brackets and this unit right here is a mirror and a mirror. I have my camera coming in here and looking at the side of that assembly. I have this camera coming in here and I'm looking at the top. And I also have another camera coming in from the end and looking at the end of that part. You can kind of see the images right here. So I'm looking at that in 3 dimensions. When I move this carrier into position, I have a guide block over here and I have a dowel pin that holds it in a given position. The operator is responsible to push it into that position, and then I have a vacuum pocket on the bottom that turns on and holds that securely. I have the same vacuum source over here at this station, so once you move it into position, that vacuum holds it down and it does a very good job of securing it. When I move this sensor carrier block from the pick and place unit to the bonding area, it again has a vacuum source and it holds the block down and continues to hold that sensor.
Ed, I'm sorry, Lynn, can I interrupt you for just 1 second? You're
Sure.
showing all the cameras in that view as well. Is the red path the field of view?
Say it one more time.
You show some cameras, and it looks like you're kind of projecting light and a field of view. Is that what the red path, the pink path is?
It is.
Okay, I wanted Brian to see that. He's our vision expert. I wanted him to see that you're looking at that from 3 different directions.
Yep, I can see what you're doing. You've got some Navatar 8000s and some 45-degree prisms, and it looks like some precision goniometer stuff going on at the end to secure your field of view. Very slick, very nice.
And
okay, good. I just wanted to make sure we saw that while we were in that view.
I understand. And our group in Nashua put this one together, and it may be a little bit of an overkill, but I had them give me 3 directional or motion on these cameras. It has worked out. You know, once you have it in position, it's no problem, but it is so handy, especially for development and to develop this project, to have all the adjustment right at my fingertips. So I have 3 adjustments, X, Y, and Z for each of the cameras. Plus I can adjust this mirror here as to where it focuses on that part. So this, and by the way, that sensor, as I put it in the end of that block and I carry that block from the other station back to this station, I have not had any problem with that part staying there. I've even dropped a block on the floor and it is a rubber pad and the part did not come out. The only thing that knocks that out very easily, there's a pocket in the bottom of this that I use for vacuum to pull that vacuum down. And if you take that block and set it onto a flat plate, there's obviously just a little bit of airflow up through that hole and it'll blow that sensor completely out of there.
They're just setting it down. Simple hydraulics.
Mm-hmm. Yes, yes. What I have here is XYZ Thorlabs stages. So I can adjust that up and X and Y here to move. And in this scenario, what I'm doing is I'm bringing the wire into a given fixed position because I've had the same locators on my carrier over in the laser area. I now bring it over here, so that wire runs very consistent as far as the location. The position of the sensor in the block varies a little bit, and I always bring it in with this down, so of course I don't hit it when I bring in the wire. And then I bring it up and then align the sensor to the wire. And let me go back. And so in my field of view from the top, I'm looking at that, and this part right now is shown 2 microns out of position. So you can see what that looks like at 2 microns out. And that is probably the most critical. I look at it also from the side, of course, with the camera, but that's where I simply bring it up and bring the sensor up to the bottom of the wire. I also look in the end. The end I don't use very often or very much for aligning the wire to the sensor. What I do use the other two a lot for is for the electrode alignment. When I bring the electrode in to do the bonding, that's where I cannot see it from the top, because obviously when I move that into position, I now have blocked my top camera. So in this view is where I see the profile of that thermode. Also on the end. Now the thermode is considerably wider than that bond, so very seldom do I need to make an adjustment side to side. That usually is very good in its location. It's pretty much the same, but not quite as robust from the side here. Because my wire is fixed on the location when I cut it in the laser, I bring it over to the same locator. It's typically very repeatable as far as where the end of that wire is and where my thermode is. So what I'm doing in my current scenario is adjusting the sensor up, down, back and forth, and in and out to get it aligned. But then the thermode is independent of that, but it seems to be very consistent with the wire.
Lynn, from a process question over here at EF, is that a heated base? I think the answer is no, but you tell me.
That is no. It is not a heated base, and the bonder itself, it's a thermal compression bond, and I don't have all these views. They're not exactly the way they should be shown, but what I have tucked in all this bunch of stuff is a Miyachi bonder, and the Miyachi weld head or bonder head, I don't show the power supply, and the power supply seems to have worked out very well. The actual thermode we have developed here at Resonetics. I was having trouble with that, and it's such a tiny bond, and we are bonding all three at the same time. I did some work on that. Anyway, I've come up with a very good electrode on the end of that. Now, it's not really an electrode, I call it that sometimes, but it's a thermode. This is our assembly where we're doing the bond, where I'm bringing in the bonder. So this is on a slide so that the head is out of the way and I can see it from the top to do my XY alignment, wire the sensor. I now bring this unit in, and I don't know if you're familiar with the Model 71 Miyachi head, but that is, it's modified considerably, but that's what that is. So once I bring it in, I then program it to come down to a pre-weld position. And when I do that, that thermode is just above that wire. So it's pretty much right about here. I typically bring that up and it pushes the wire up a slight amount to where I pretty much touch that. And then it comes on down and does the bonding. So when I bring it down to my initial position, I can see if I'm in the right position. Like I said, very seldom do I need to change that.
Great backup. Lynn, is that a pulse tip, or are you storing the heat in the thermode and then bringing it down with no heat, allowing it to transfer?
I bring it down with no heat, and when it comes down and does the bond, it's very similar to a resistance weld where it comes down.
Unloading.
Yes. So.
Yes.
So it is a pulse tip.
It'll be at stasis by the time the solder joint, the joint is made.
Just so when it comes down, then it puts the heat in.
One more time. So So when you come down, you make the compression at about 10 grams, and then you energize. Is that what you're doing?
That is correct.
All right. Yeah.
There is a switch that's not shown on this view, but there's a switch built into that Miyachi head. And when this unit comes on down by means of that servo motor, this comes on down and it makes that switch. It stops the downward motion because now it has preloaded that spring, and it triggers a switch and triggers the electric circuit to run the current through that. You can program in a delay, and then of course you program in the ramp up, the bond time, and the ramp down.
10 grams.
That's the strain block right there.
So they drive down until they see 10 grams before
Yes.
it stops.
That's correct.
Now, because, and this portion down here is Resonetics portion. We created these, I mean, we just bought these two slides, Thorlab slides, which gives us the adjustment for side to side, so I can align that with the wire also in the other direction. I can align that, and again, that doesn't need adjustment very often.
That's all.
I have a hand here, handheld handle here, and a push button here. That releases the lock, allowing this assembly to move forward and back. Now, I have never liked this head very well, and here is the reasons. And by the way, I'm running about 220 grams of force on that thermo. You can see with this design, and forget about this shaft up here, this comes up with two bearings up into this unit, and that is the means that guides this unit as it floats up and down. And then this spring in turn pushes this down, and you adjust that for the amount of force you want. With that cantilevered distance here, and because it is so small, any motion in this direction causes me. So after I put this in operation, I actually ended up making a longer shaft for here. I put a couple bearings in here and preloaded it. So it still has free motion, but it tends to help as far as any cantilever motion that is moving out. The Miyachi, this Model 71, I don't think it was ever intended for something this small. And the way you adjust that is on the controller. You can adjust your post-stop or your pre-stop before the weld. So you bring that down to X distance above the part, and then you can come on down and do the weld. That is way too coarse, and I can't get to the exact position that I'd like to get to. So when I go forward, I don't want to use a Miyachi head. The power supply is perfectly fine. Haven't had a bit of trouble with that. And that, but the motion, and all I really need to do is to come over and put a very consistent force on that part and make sure I don't move side to side, back or forward when I come down with that force. It needs to be very consistent on the top of that part. Once I'm down, I need to know that with a given force and then trigger the electrical circuit.
Give it out.
Yeah.
So, any questions on what I'm doing there?
Not yet. Have you thought about, instead of using shaft guidance on there, using cross rollers on the bond head?
Instead of using what?
Well, right now it looks like you got a shaft bearing out there.
There is a linear bearing in here that came with the Miyachi unit, and that's what I'm using right now to guide that thing. I've thought about trying to go with something. I'm a little concerned. I mean, it's a balance between, if I have much preload, that'll give me more rigidity. but it also provides less accuracy on the force because then you have to overcome the preloading bearing.
Get the weight of the carriage, which is going to work against you, but worse yet, on the bearings, you're going to get your stiffness, but you're going to get the stiction of the bearing, which will false read on your Graham's force, depending. Huge.
And if we can work another way around this camera, you know, all I want to do is put some force on there. So as long as I can get it into position and put a consistent force, if I could even make a U-shaped bracket, something like that, where I have this higher, some method that I can put the force directly over the bond, I think there's many ways that I could keep that accurately positioned. Now, what I had them do is build in also a load cell on here so I can check my force anytime I want, simply move it back in the park position.
Load cell. That's what I would recommend.
And bring it down.
If you want to make that as stiff as you need, and what I'll do is I'll tell the servo to stop at 230 grams of holding force, whatever it is.
Now, the last step, and what I have here is simply an inspection station. So once, whether it's cutting it off, bonding, or the epoxy station, I can bring it over here and snap an image, look at an image of my part. So I've got that. That was kind of an afterthought, and it worked out real well. I spread this apart and put this cable in here. It doesn't look the greatest, but it works functionally. And also you have these two carriers and they have an umbilical cord on, so you got to make sure they don't get one. Now, the last thing I do then is bring this over and dock it in the air vac station again. Again, vacuum holds that part down. And here, and I don't have all the details shown in this view, but I bring that over and the head is equipped with a dispensed nozzle. It looks at it first with the vision system to find it. It then brings it over and deposits the epoxy on that. It then brings camera back and looks at it a second time. It then moves, and what we've added to this air vac system, and again, I don't show the detail in this view, but there is a UV light guide that I have mounted on that, and it comes over and does the curing. Once that is cured, I again look and do a final inspection on that part, and then I'm complete. I take that spool off of that curing.
The product is the part rolled up on the spool, the little tooth tape holding it. Well, you saw that. I brought that in.
Now, that is the semi-automated system, and the customer would like to go to a fully automated system. They do expect production rates to go up considerably. So let me bring up some concepts on that. Close this out because that is a big file. I've got several concepts that I've worked with, some as an index dial type system. The one that I think will make the most sense is maybe a robot to move the carrier around from station to station. And I'm going to stay on the line, but I'm going to go get me some water if you don't mind. I ran out of water.
Oh, feel free.
I'm doing a lot of talking here. Excuse me. Okay, I'm back. Okay, what I have shown here is my incoming spool dispenser and my carrier. And again, keep in mind that this can change configuration. So if I could use a robot, would be great. Pull that wire through there and get it secured to that spool. I realize that maybe to start out, or if everybody is not comfortable with doing that automatically as far as taping that, I may have to have an operator interface there. So I secure the wire, I pull it out, and here what I had looked at early on was IPG lasers. I figured on my other system, my current system now, Steve, I mentioned that we bought that from Laser Wire Solutions.
Laser Wire Solutions, yeah.
It works. It's not great. I mean, when it's working in production, it's fine, but it's difficult to make change. A good alternative.
I'm thinking you sent a lot of information over, and I know they're digesting. They're going to get back to us and see if we've got some other streamline that as well. But yeah, for now, we'll just think of it as a laser stripping station, not with any particular brand on it.
Okay.
You're showing it as a dual galvo system, top and bottom, correct?
I am, and that's what we have now, except that it's got a beam splitter now. It's one source.
Okay.
So, but just consider that a laser. So yeah, we have a laser in it. Now, as far as our current experience, when I dock my carrier, it does seem to be very repeatable. Now, I'm guiding it along one edge and then coming to a stop on the front face of this area right here. And then the bottom side of these hollowed out somewhat, so when I pull vacuum, I got plenty of surface area to pull vacuum on that. I'm not saying that's the way we have to do it, but that's the way we do it now. Right now, we have a spool retainer over here that I simply stick on this side of that spool. It'd be nice maybe if I can stick that spool on, and maybe there's something that grips it on this side and leaves this exposed, but that's details further down. So kind of my thought here, and I'm open to a lot of different, different ideas, but if we could use a robot in here to move these around, and what I thought was we dock this here, and we have several of these carriers. The one thing that I haven't figured out exactly how to do yet is to keep the shield gas and the vacuum on that part until I go through the bonder. So here and here, I need to somehow continually have argon flow on the end of that part. Now, just to throw this together, I showed here a separate pick-and-place unit that would place that sensor from a wafer to my fixture block for the sensor, and then maybe a separate pick-and-place. This could be configured quite a bit different. However, it would be great if, and I know there's people that make the wafer pickers. I mean, AirVac is one that, they can pick directly from the wafer and go to a given point. Maybe you guys, feel comfortable making that. Maybe you'd make them. I'm not certain on that. But if we had the pick and place right here, and we could pick it to a given fixed point, and that never moved, and then this unit would move back to pick up the next one, and part of this unit would be the bonder. So maybe you have a separate unit here. This one maybe is back here picking from a wafer, and then the bonder moves over, and then it can move accordingly and then bond right there at that position in this same station. Now, the way that I'm proposing here that's different than my other one, here I'm planning to move the wire and align it to the sensor versus aligning the sensor to the wire. Now, if I was to do my bonding right here in the same pick-and-place unit, the one advantage could be that I got a fixed point. I'm always coming to that same point and it never moves. But then I also have to have clearance to get vision in from the end and the side. So when I do my bonding, I can see where my electrode or my thermode is. So,
excuse me, this is Brian asking a quick question for you. How certain are you of the conductor-to-conductor spacing? Is there any uncertainty in the center-to-center pitch of those 48 gauge wires?
Currently, the supplier of the wire, I'll just tell you, it's MWS is who's supplying the wire at this point. And what our spec is plus or minus 3 microns.
An eighth of a thou.
I don't have the right one here. Let me open the other file. Open. But your question is, how accurate are the spacing on this wire? I am actually amazed at how consistent they are. Now, what I'm asking from you folks is, I realize there's going to be some variability on that, and what I would expect you to do is to align the center wire to the center pad. Can't do any better than that. Yeah.
If you had to do some kind of sequential bonding to where you tack them down one at a time, moving them laterally to stick them down one at a time and move them.
That's wire bonding.
Yeah, no, wire bonding doesn't work that way.
Yep, understood.
Yeah, and it has proven very successful to bond them all at the same time. And so just figure that you align the center pad to the center wire.
The ball, you get the wire, you're going to try to squeeze that thing in there on a wedge bond.
Yeah.
And then you got ultrasonic to do it with.
Yeah, no, I'm not doing that.
Now, just for concept, I just dropped in my XYZ, but obviously this, and what I'm thinking at this point, and Steve, you and I, have had some communication about the accuracy of the robot, so I would not expect the robot to position it accurately with that unit. All the robot would do is, move it into a docking station, and then I'd have
nugget,
very precise XYZ that coordinates with the vision system, so I can align the wire to the sensor.
Yeah.
From there, I no longer need to retain that argon flow across the end of the part. However, I am going to need to retain that vacuum, or I think that's going to move unless there's another good way to do that, which I don't know what it is yet. This station would be the laser cleaning station. And Steve, like you talked on that laser, it does have through the lens viewing. So we're going to have some variability in where this is positioned left to right.
Yeah.
A laser, as it cleans it, I would think it could swipe, it could do a pattern across this way, and I don't care. I can give it, plenty of distance on the sides. But forward, left to right, I don't want it getting into this insulation. I don't want it getting too far down here. So I will need to know where that part is so that I have a hatch area here that I do laser cleaning on.
Good application of the vision integration on that laser.
I understand, yes. Okay, this station then would be the epoxy dispense, and what I'm sure I'm going to have to do again is to bring vision in to find the exact location of my part before I deposit that epoxy. Now, what I figure is once I put that epoxy on there, somewhere in this station, I need to have the UV light where I can at least do an initial cure once I deposit epoxy. Now, from there, I probably don't even need the vacuum. It's probably secured enough in the end of that part. I got to make sure of that, but then this could be, this is just one idea, but I know that Mike, you sent me some information on there is an oven that maybe I could just put them on a conveyor and just run them through an oven. And actually, well, that's not the right term. It's not an oven, but it is a device that has the UV light where it will cure that as it passes through.
We would either build that or use multiple UV lights or a moving emission source. But I think that your cure time is pretty excessive for some reason. I would also look into that right away.
We need to have, the customer has asked for 2 minutes. Currently, we're using 45 seconds. I can't get Epotech to give me an exact time, but I realize that there is so many variables that make that up. How thick it is, the substrate, all, I mean, there's so many things that go into that. And I don't claim to be an expert when it comes to epoxy. But the customer asked for 2 minutes. I think the only reason they did was because there is one document that says something about 2 minutes. And it's the Epotech OGP 116 is the epoxy.
I would talk to Epotech about that. I know this material has been specified for the application, so there's no changing it. I understand that. But is the cure vehicle like already fixed in that design as well?
I think that I can use less than 2 minutes. Is that what you're asking?
Yeah, I would hope so. That it seems like something's wrong that you had so much time required to cure, you know, a microliter, you know, droplet of material. But then again, you know,
I think it is the material itself, because we have some epoxy that we're doing out here now. Probably 2 seconds, you know, it's pretty much cured.
Yeah, 2 seconds sounds much more realistic. It might be wavelength, it might be power, there could be some other things in there as well. But you know, that's our bottleneck. That's our bottleneck. When somebody says, you know, and this last process takes 45 seconds, that means that if you build obviously a serially, you know, progressive machine, the fastest you're going to do is one part every 45 seconds, unless you start splitting that up into, as you show it, you know, 4 cure stations, 5, 6, whatever. But to me, that needs some more process development, or at least some discovery, because it seems like something's wrong, honestly.
I don't think so. I did think so originally, but we did enough work on this that I think this epoxy is different than many. And
okay.
I know that they're very specific on the wavelength, you know, and all that. I don't want to rule that out, but don't count on that, because and we've had some issues as far as the bonding of that to the sensor. We're working through that anyway. But my thought here was, I mean, if we had a conveyor type system and we could flood the area with light, I could put it on one end, bring it out the other, and then like you see, I have multiples and I can get my extra time. Or the robot could place, you know, pick and place one here, and then the next time it picks and place one here, and so on and so forth. So it always has enough time in the station, and then it ends up out in the final inspection area. We have to do inspection, especially at the end, it probably would be a good idea to have an inspection area before we put the epoxy on it. And I want to capture those images, store them. Now, one thing I need to do at the end is actually do the resistance check. Now, I have those 10 millimeter length of wires that are extending that have been stripped. They tend to tangle, and maybe there's a better way of doing that, but when you strip them, of course, it's adding heat to the process, and they tend to kind of tangle together somewhat.
Yeah.
If there's a way to automatically do that, that would be great. But I'm certainly not counting on that. I still may need an operator there to take care of that part. Now, I guess one of my questions, and maybe you guys have any questions too, but with the alignment, how confident do you feel that you can do that with a vision system?
It would be a vision system that was tied into what we're still debating here amongst ourselves, but probably would be a PI precision piezo. And I feel that if Brian thinks we can get the image good enough, then yes, we can servo those into position. And it sounds complex, but it's being done, and it's not awful. But my question would really be more on the vision side, as far as level of contrast and those sorts of things. Is there any way you can show any of the images that have come off of your cameras?
Well,
yes,
Steve,
I can take some, but
some of the basic physics that we have to address would be, we've got diffraction limits. I see that you're using fiber optic, probably halogen source. I saw some shot light engines underneath the table, and we could probably do some things with more of a monochromatic light. We pay good attention to the depth of field and make certain that we have the, I guess you'd call it the working distance infinitely controllable, so that we could be certain to be at our focus point being at the widest part of the equator of the wire, so that we're thoroughly in focus with a wavelength of light that behaves well through the lens. I saw you using Navitar lenses. I think they were Zoom 8000s or 12,000s. And there's also some really nice Michitoyo lenses that use microscope objectives on top of some other lens bodies. So getting the resolution in the lens and the image quality is one thing, and then calibrating to world units is the other thing. So we need to, although it's a very small field of view and very nearly telecentric, but we'd want to establish some kind of a robot to camera rationalization system where the coordinate systems of the camera and the robots can be tied together accurately. And that can be done just by moving some very small feature pins around inside of the camera's field of view to say, here we're at the left corner, we're at upper left, upper right, lower left, lower right, and some points in between, and to actually build a coordinate grid that we tie the motion control and the camera together in that way.
Okay.
So, and interpolate in between.
And yes, I understand.
There's a lot of questions, but it's all there. It's all there. It could be a microscope or a telescope, and it's kind of the same problem, but we just have to mind our image quality.
And like you're saying, you need to map it. Maybe you can do that before the wire's in position, and then you could just use one of the bond pads, something like that.
Yeah,
now,
and then what I'm talking about for mapping is just a matter of establishing calibration and traveling to a few known points and making certain we're all still.
And I am by no means a vision expert in any manner. And I know
you look like
that
you're
we
doing
don't
fine
have
so
our.
far.
Tell me all about
Well,
it.
the one that we have out here, I know there's better lighting and better ways of doing that. It's just I don't have that skill set. And they put it together up in Nashua. Getting time and getting the right people down here to help is, it's a little bit of an issue. But I know that it could be much crisper than what I have. It's probably mainly lighting, I'm guessing. I'm just not an expert in that area at all.
Yeah, and it's a matter of going through your modulation functions and then you getting the lens and the light and everything working together, and that's what we do. We could certainly give you some direction in that way.
Good. Yes. Well, that is certainly one of my concerns. I think that's the heart of we absolutely have to make sure that we can align this correct. And it sounds like you're gaining confidence that you can do that. Sounds like maybe you need to do some testing, but the only other backdoor approach, and I hope this wouldn't be required, is to have an operator screen and he sees the images on the screen and he has a joystick or whatever, to make some adjustments. But
that certainly shouldn't be necessary because the resolution of your camera would be able to detect features well under the micron levels that you're after. And you might as well use all of those edge tools and pattern finder tools and all the neat software sets that come with cameras these days to give you the number out to as many decimal places as you can imagine. So.
Well, that's the right answer.
Okay.
The right camera, the right field of view, the right objectives, the right illumination, and then the right software to tie it all together. That's to the party here, and this is that particular expertise of the Reliabotics group, and it doesn't scare us. Obviously, there's an integration, there's lines of code that have to be written. This thing to function quickly and flawlessly, that's the way to do it, not interrupt in the middle and give an operator a pantograph motion system to do alignment and like that. We'll do it just like they do in the wafer bonding or the tab bonding, industry.
And the low-hanging fruit that's there for you is that, I'm sorry, go ahead.
All I was going to say is that's certainly what I'm hoping for, is a completely automated system, because I don't want to have operator intervention, but it's just an area I don't have a lot of expertise in, and I want to make sure somebody does have that.
Right. Yeah, no, the low-hanging fruit I was talking about was that you're also going to get the data with the measurement system. So if you're curious about how much some of these process variables are drifting from batch to batch, lot to lot, you've got easy access to data that you may or may not want to log, but it's certainly there. Certainly there for you.
Good. That sounds great. Yes. Now, the other thing that concerns me, have you guys have any experience with dispensing tape?
Yeah, that's a chief concern here too, because you can meter off a piece of tape, cut it to dimension, reach over, pick and place it. The issue isn't really the tape as much as it is trying to get the wire underneath the tape and everything to line up as you're kind of, taping that edge down. I think it could require some, discovery, but it's not unlike what isn't being done in the circuit board industry, where they're dispensing a small adhesive label, picking and placing it onto the circuit board, right, Mike? Thought Mike Young might still be with us.
Yeah. Okay. Maybe. Yeah. Okay. And as far as the wire, let me tell you this: we do have some amount of braking on this so that it doesn't freewheel when we dispense the wire. In addition to that, we have vacuum that's pulling it down through here, and we have vacuum that's pulling it down through here. So when we pull that through, and I realize these lids are going to be different. They're going to be automated. They're going to be whatever, if we need them at all. But anyway, once we pull that through that area, you have some amount of tension in the wire, so you have some control. So if I bring it up, I can bring it up and touch the bottom tangent to the bottom of that spool or the top or whatever. And then I think that I could control it pretty good, put a piece of tape on it. But again, I've never done that. I don't know.
We could show you what some of the concepts are and some of the other equipment that we could see and take inspiration from. It's kind of a shame to take such a high-tech product and then have to put a piece of tape on it, but I guess it's what the doctor's expecting or the surgeon's expecting in the operating room. So.
Now, once we tape that wire on there and then we wind it, obviously the end, there's some length there that's just kind of flopping around. Like I said, this may be best vertical, I don't know, but we probably ought to, at some point, decide how best to manage the end of that wire. We're not doing a great job now. I have a concept that I'm working with to secure the end of that as it's wound up. And in addition to that, it might help to give us a spot to check the resistance if we can secure that end of that wire somehow.
That was Mike.
See, Lynn, if I could back up just a little bit, I think you were talking about doing an inspection prior to the epoxy being applied. Was that just a geometric inspection, just making certain that the dimensions are right and that your components are all lined up and secure? Or was there some cleaning aspect in the inspection as well?
After the cleaning, I'd like to, yes, I would like to gather that information, but also inspect for debris on that.
Right, debris, okay. Any ideas on the specs on the debris?
No.
Okay. Really small.
Visually, we look at, yeah. Visually, we see it on screen now, and I don't have a spec on it.
Yeah, understood. Yeah, it's just one of those things. We'll have a high magnification for the alignment portion. Maybe there's similar order of magnitude there for debris as well. So.
Yes, and okay. It's really only looking at it from the top. I only need to look at it from the top at that point.
Right. And okay, very good. Thank you.
Okay. Hey, quick question, Lynn. Productivity on this machine, whether it's hourly or annualized or whatever, what kind of throughput numbers are you projecting, based on future growth that you're going to justify this machine against? Is it as we said, you'd like to do one every 30 seconds, or is it even faster? Or?
What I want to do, and what our customers requested, and I did throughout the 30 seconds, and maybe I shouldn't have, but the customer expects that he's going to require more production than this one system can produce. If I want to get it as fast as I can reasonably get it without crossing a line where the price spikes. So,
okay.
You have, right now we're taking, I think, about 20 seconds to do the stripping on that wire. I don't know if it has to be there. I think if it was optimized, maybe we had, that other laser. I don't know. Maybe it could be faster than that. The bonding, obviously, it only takes a second or two to actually do the bonding. We have to have time, of course, to get everything lined up and in position and exchanged and whatever. Epoxy and, the laser cleaning, I wouldn't think would take very long. The epoxy, I wouldn't think. And we can adjust how this is cured to accommodate pretty much whatever cycle time. So I would like you to focus on what you think is reasonably fast. I would certainly hope it's not more than 30 seconds, but it would be great if we can do under 30.
We'll have to do some sort of time study on this and then look at the number of stations, because obviously if you start duplicating stations, you can increase throughput. But that's what you're talking about as far as your dollar spike, where you say, oh, now I need 2 sets of laser strippers or 2 sets of cleaners, or, you know, those types of things, which are, you know, expensive solutions.
And it almost appeared that it's not too far out of line as far as my timing right now, you know, my laser time, and then by the time I pick and place a sensor and I put this in position and then do the bonding and laser stripping, that's piece of cake. I mean, that shouldn't take long at all, although I haven't done development, so I guess I shouldn't say that until I do it.
What happens with the residuals from laser stripping and from laser cleaning?
What we have on the laser stripping and cutting, there is a vacuum source built into that system, or not built in, but it's connected to it. And it's a fume eliminator system. So it tends to pull off any of that debris, and we will need that.
And laser cleaning?
And the laser cleaning, I haven't given that a lot of thought because I'm not doing it yet. I know it is such a minute amount that I'm removing, but I still probably ought to capture it.
You're
affect your bond.
You're disassociating that, and I can tell you that if push comes to shove, we can use our CO2 microblast cleaning system on this part. I just think it can be done with laser, you know, same technology, but we definitely can do a very needle type, you know, quality. So I won't spend a lot of time on cleaning. I think we can solve that in, you know, a variety of different ways. Yep. But I am curious, what's your when you're flying on this semi-automatic system, how many are you putting out?
Right now, well, the way it was concepted, I figured I could do 100 and about. Well, let me back up. We're doing right now about 75 per shift. That is nowhere near as efficient as I expect it to be, and I think we can be. But I think we can probably get down to 4 minutes, maybe 4 minutes apart with this semi-automatic system.
10 an hour right now. Yeah. How long does the bulk wire hold out on you? It doesn't look like a big spool.
That could be adjusted, but there's 15,000 meters on that. And
take up a lot of room. Wow.
that wire's pretty small.
Yeah. Okay.
So it lasts a while. Yeah.
All right.
And the wafer, I believe they said the wafer is going to have like 7,000 parts on it, so won't have to change that wafer very often.
7,000 parts on a wafer, 15,000 meters of material on a wire. Is there any residual solder or plating on that pad? Is that what creates the bond? Is there some sort of plating that bonds into, or are those just two materials that are being
not
together?
Yeah, it is simply the copper. It's the copper to the platinum, and it creates it's a semi-solid bond between the two with a combination of pressure and temperature.
Yeah, you're just creating intermetallic by commingling those two materials together. Yeah.
Yes, that is correct.
Okay. Thermode material you settled on?
Yes, we're using, can't think of the name of it right now, the name of the material, but, it's moly. Yeah, we're using moly. And I actually designed that up and had one of the few shops that I could find that had a 4,000 wire EDM. I had them make that with wire EDM.
Okay.
What capability do you guys have as far as the smallest wire EDM?
Wire EDM.
We have nothing in-house for wired in.
Nothing for that size. Well,
We don't have wired in here, so we'd be outside.
so we sub that.
Yeah.
Okay. Yeah, I don't know why they need to pick from wafer. It must be cost to put it in a gel pack.
It is, I believe. And I mean, because you can imagine going from 7,000, I think it's 7,200 actually, down to 100 per gel pack. Get a lot of gel packs.
What's the diameter on the wafer?
I think it's 6 or 7 inch. I can get you the details on that wafer.
There's a lot of tension on the nitto tape for a week and a half.
Let us talk to the engineer that spec'd out the die pick that you say your customer has, because it looks like with a larger diameter wafer like this, it's going to sit on the nitto teeth for somewhere between a week to a week and a half. And there's a lot of weird things that happen with the adhesive and the expansion of the materials based on temperature, humidity, those kinds of things. And we're wondering if maybe by the time you get to the end of that week and a half, if you now maybe have set yourself up for extraction forces that were higher than what you had before, or coplanarity issues, or the push off, from the backside. If there's somebody we can talk to, it might be helpful. It just sounds like a lot of material.
Why don't I start with, let me get you information on that wafer, on what they're doing now, and then see, let's go from there. I will get you.
Yeah, and I'd like to see how far they expand it and how big the lanes are. That's what I'm thinking.
Okay. Now, Steve, I know you guys don't make equipment specifically to pick from a wafer. Now,
that's correct.
EF Precision.
They've done
Precision.
It.
What? Okay.
They've done it. They don't have standard product for any of that, but they've done wafer pick systems and precisers and things like that. I'll let Rich tell you about his experience there. I don't know about this die size.
The die size, I'd have to go back in the Wayback Machine. I've cut my teeth on tab bonding, automatic material handling, automatic wafer handling. Everything that you're doing there is where I cut my teeth and spent many years making all that work and putting instrumentation in it and everything. The nitto tape just gets interesting over time. That is my concern, because you're stretching it to keep it taut and to pull the streets apart, or the kerf, however you want to refer to it as. And yeah, it's under vacuum when you're picking, but then you release, and after a period of time, does the material misbehave? So we've kind of got to go and find it. And you can find the die again. That's not a problem. The question is, when you draw down on vacuum, will the nitto tape stay flat? And your pickup tool should work, but what you might need? Gosh, that's going to be so hard. A secondary precising after you pick it off the nitto tape in case it skips off the pickup tool. If it came into a secondary precising station, that would help get your coordinates right orthogonally, so that when you place it in that little holder, the world is perfect.
You having a problem with that now, Lynn? You having to do any kind of precising to center it on the end of the vacuum tool?
They're doing it at a gel pack.
Yeah, that's right. On gel pack, it's much more stationary.
And the gel pack we had to work with, so it had the right amount of retention, because first ones we had obviously stuck too good and it wouldn't pick it off there. But,
I could see that happening.
What I would picture, yeah.
But we've zeroed in on the right one, and we really don't hardly ever have a problem with that. And the airback system goes over and, of course, it looks and finds the next one first. And then it goes over and picks that up, and then it looks at it from the bottom to get it radial orientation. And then it comes over and looks at my fixture, and then it goes and places it into the fixture. And that's working quite well. And we bought the nozzles from Nozzle Supply. He's developed a nozzle, seem to work well. Now, my thought on this pick and place unit, you know, I know there's several suppliers out there that make these, and I'm not, and I don't know if you ever would even do this, but I'm not looking to reinvent the wheel, you know, by trying to create one, even though it could be somewhat custom, knowing that there's ones out there that can do this. But, you know, so that's just kind of my thoughts. Now, I will tell you at this point that our customer is using, and I don't know if they're doing it, somebody is using a Royce Instruments unit, and I believe they're picking from that wafer and placing it onto that gel pack.
That's how you're getting on gel pack. They're sub-packaging for you.
Yeah.
Yes, and the Royce Instruments, I went out there and when I visited the customer, I actually visited Royce Instruments.
Yeah. Yeah, and voice oil, yeah, oh my God.
So we can point out one thing with that process, Lynn. If they're just bulk picking from, you know, from the wafer and putting it into a gel pack, that Nitto tape is probably being replaced in an hour.
Yeah. It doesn't have time for gravity to take over, or
right.
age, or
so
heat,
the things that Rich is commenting on could definitely play into the environment, you know, of a big wafer like that taking weeks to put together.
I do understand that, and that's something that I'll admit I don't have any experience with, and it's a good, you know, it's a good point that you brought up. I want to make sure we don't run into that problem. So yes, let me get you more information on that wafer.
We could do dry nitrogen.
Environmental.
Yeah.
Dry nitrogen is yes, it'll work. The downfall is operator safety. You got to now make sure you got load lots and everything else like that. And yeah, and O2 sensors. And
we do that in our CO2 cleaning systems for the same reason.
Yep.
Even though nobody can, and they're afraid they can.
Yep.
Sorry, little inside pool here on environmentals. You say this should probably be done in a class 10,000 clean room. Is that correct?
Yes, the customer is going to insist on class 7 or 10,000.
Okay.
The room.
Now, tell me a little more about your CO2 cleaning. How does that work? What is it?
Sure. If you're interested in a real thorough deep dive, we'll probably go offline, you know, and do that where we could really talk about it in whole. But what we do is we take beverage grade CO2 in either liquid or gaseous form, controlling heat and temperature and pressure. We can actually expand it using Joule Thomson to create particles as small as a few microns. Usually somewhere in the neighborhood of 1 to 5 micron is the particle, you know, size. And then we actually blast with that just like a sandblaster with either ultra purified air or dry nitrogen, or actually it can be done with CO2 gas as well. But we eject a stream of particles to the surface, and the hardness of the particles is about 2 to 3 mo on the hardness scale, about the same as your fingernail. So it can do a really good job with kinetic energy to knock things around and off surfaces, but that's not the only way that CO2 cleans. You see, when you intercept it as a solid, just before it becomes it sublimates into a gas, it actually goes through a state where it can exist as a supercritical fluid. As a supercritical fluid, it's an excellent solvent an organic solvent. And so it can absorb and combine with hydrocarbons and things like that as well. The only thing that we do is we put all those dirt particles, materials, etc., into suspension, because the CO2 particle, when it hits the surface, it expands to about 800 times its original size. So think of it as little bunker busters going off on the surface, blowing everything up into the air. And then we have an entrained airflow that sits over top of that. Usually it's at 90 degrees, and it takes it straight into a HEPA filtration system where all the particles are then basically captured. Again, using airflow in one direction, we don't have to worry then at that point about the particles coming back and resettling on the surface. We have really good documentation and evidence in the semiconductor, the disk drive industry, et cetera, for being able to remove everything and leave zero particles behind, which sets you up for some really excellent bonds with adhesives. And if that's not good enough, we can also then come in right afterwards and hit it with a very small amount of atmospheric plasma, which will take off the last nanometer of whatever material is remaining behind, and at the same time usually do a really good job of raising surface energies on the non-metallics so that we can get a better bond and a lower wetting angle, higher surface energy. And I would tackle that for you independently, process some samples, package them up, get them back to you, and you could see firsthand. We're not going to leave anything behind. So as far as having to use a vision system to look for inclusions and things like that, I just don't think you would need it once we optimize the cleaning process. And as I said before, it could be either laser, or it could be CO2, or it could be CO2 by itself, or CO2 with plasma. We'll optimize that for you.
Now, I don't know much about the cleaning process with CO2 or plasma, but plasma, I believe, will create some electrical energy around that part, right?
There are systems that are specifically designed not to create ESD charges, which are capable of damaging active devices. They're a little bit more money. They have some proprietary technology in there that allows that to maintain the shunted equivalent of zero voltage.
Okay.
And this is being done in small point source plasma sources. I'm not talking about systems that put it into a vacuum chamber and mixed gas plasmas or anything like that. I'm talking about atmospheric plasma.
And keep in mind with the CO2, from what you're describing, sounds promising, except that if you can imagine 3 human hairs hanging out the end of the holder, how much force am I going to hit that with, and is it going to bend the wire down and all that?
You're right. We have to develop a process that has the lowest propulsion driving forces for the particles that can get the job done without creating damage. And I know for a fact that we've done this trying to clean wire bonds, and without an optimized process, it looks like a tornado went through your forest. Absolutely true. The advantage you have is that everything's bonded, everything's flat, and we can hold on to it. Whereas a wire bond, as you know, has that up and over loop. What do they call that?
The only time you can really hold on to it, and this may be possible, is at the bonding area. I've already got the sensor in that holder, and I've brought the wire in. I've now made my bond.
Okay.
I don't know if it's possible to maybe bring a nozzle over at that point, still continue to hold it in that sensor holder, and do some cleaning right there at that point before I let go of it. Because once I let go of it, it's almost like
a puff. It's almost like a puff at this point. We would come over with the CO2 particles already emitting, and then we got into position. We would just blow momentarily to take care of the the debris. And I think it would happen in a fraction of a second, to be honest with you. But I would have to test this. I'd have to build a station that I could put underneath of a microscope, and then we could actually do some testing and development on that.
I would be perfectly fine with. In fact, I think I'd be very pleased if that could do it. I mean, I'm not certain laser's best choice. I was just thinking that maybe I could try that. It sounds like you're more knowledgeable on the plasma that I have found as well, because everybody I talked to about the plasma, it's a much bigger scale than what this is.
Yeah, plasma works fantastic if you can get rid of the gross contamination. Plasma cannot get rid of gross contamination. So if you have any kind of a residual oil or anything like that, I mean, it has to be nanometers thick for plasma to act on it. But yeah, we'll tackle the cleaning portion. The RSTG, the Service Technologies Group, that's what they exist for. And I will send you some white papers that show what we've done in the world of not wafer bonding. I've got some white papers from the EMPF that show what we've done in flip chip bonding and wedge bonding and ball bonding. And
okay.
the pull-off forces are definitely increased tremendously. And of course that equates to, long-term stability of the joint as well over time. Although this is a disposable device, correct?
Yes, although I can't say that 100% because I know there's a lot of different markets they've talked about. So
okay,
a majority, well, almost 100% that I know of right now, yes, is a disposable.
Okay, it's not an electrode on a pacemaker that they're leaving inside the body for 10 years at a time. In other words,
that is correct. It is not.
Okay, got it. All right. So, what is the purpose of the encapsulation? Is that just to make sure that the wire doesn't break? It's basically like strain forming.
Two things. It does add strength to that bond, but this device works in a liquid, so it has to be isolated from that liquid.
I think it's actually in blood, in your vein. Okay.
I know that the idea of getting the cleaning optimized is probably the first priority, but we do operate in scenarios where we do a before and after vision inspection as well. And
yeah, if the cameras are there, we can do it. You're right. Yep.
Yeah, doing a before and after can show whether you're going the right direction and whether you've made it all the way home.
I understand.
Brian, in your lab, do you have any of these, high macroscopic objectives that, we could use to prove that out? Because I don't here in New Brunswick. I'm just mentioning it.
I can certainly get my hands on them in short order. I don't like to keep museum pieces around. I mean, these are fairly exotic pieces we're talking about, so we can get our hands on them within at a very reasonable time.
Okay, very good, very good. I will start looking at stages. I think that we need to have a discussion about nidotape with somebody. And I guess the rest of it really, to me, Rich, is have you seen anything here? Well, what did you want to talk about? You're 75
years old?
No. I'm not 75 either. So, I don't want to be 75 when we make this thing work either. So. There's always the question, how many are you doing now, and how much faster does the machine have to be? And, how many machines is it going to take in order to meet that volume?
So you're doing 75 per shift right now. We're assuming that's an 8-hour shift?
That is an 8-hour, well, it's actually a 7.5 hour because we work 24 hours a day. So the operator is taking breaks, and so it's actually about 7 hours working time.
So it's a little bit better than almost 7 minutes per, right?
That's right. And I fully expect that I can get down to 5 minutes apart. I know some are not that optimistic, but I'm sure I can do it. So.
And that's because of the hand processes that are associated with winding, getting the measurement set up, taping by hand, hand
right
loading
now,
and unloading your fixture.
That is correct. And right now, I mean, every so many parts we do a pull test. So of course you have a fallout from that. And then of course the epoxy on our current system, we knew it wasn't ideal, and it gives us a little problems every now and then. You got to stop and mess with that. But so all that coming in play adds to the time.
That was the next question on my list.
How many pull tests are you doing out of a day's production?
Right now we're doing 1 every 10.
Wow. Okay.
And as we build confidence, that's going to go, less often. But right now it's 1.
Okay. What constitutes a failure? You said you sent a lot of these out and some of them failed. What was the typical defect?
Okay, let me talk about the pull test first. We do that pull test here, and what happens there is when we have a good pull test, the bond does not break. It breaks the wires. They thin out and break. So the bonded copper stays on the platinum. Now, the failed parts that we have had so far from the customer, it has been water leakage between the epoxy and the sensor.
Yeah. And that's what plasma is about.
Okay. Going right into the capillary of the overmold conductor insulation. Okay.
Plasma, I think.
Yeah, it'll
you can
swing
get it
right
on the
in
wire,
there. Yep.
Get it on the wire and everything, and you'll activate that surface energy. So hopefully the epoxy cures better.
Yeah.
So long as it's not moving.
Yeah.
So know what I mean?
Yep.
It's stable. But it should help that a lot.
There's only one company I know that does atmospheric plasma with zero discharge for active electronic devices. It's not a cheap piece of equipment.
I bet it's not.
Yeah, it's pretty expensive.
Yeah.
But we'll look at it. Rich seems to think that your solution for getting the overmold to bond very effectively into the wire insulation and giving you that sealing that you need is probably one of the greatest advantages of plasma. So
Okay.
we'll definitely want to look at that.
Okay.
So he's curing in 10 seconds. 10 seconds right now.
No way.
Why the math doesn't work out.
Math doesn't work out on your cure times?
Doesn't work out per minute on the first shift.
Okay. Hey, Lynn?
Yes.
Talk to us about the cure times. Bud just did some math and said it looks like you're leaving about 10 seconds worth of cure time. Does that sound wrong?
Hold on just a minute.
Just doesn't make sense to lose them out of the fixture. It's like I got to keep it in the fixture for every one of these processes, including the cure time, which means you're...
Yes, no, I don't think cure times do. I think you got lots of. I think you need to have stations outside and then move in independently. So you have, wherever you get that process of cure time, like that slide down, over, back in.
Straight back.
And then, but once you're running,
Circulate.
you're not losing time.
You never let go of the part.
But you guys keep on, you shift it outside your flow line
Mm-hmm.
until you have that whatever, I don't care if it takes an hour in cure time. Keep sliding it out, but once you're wet,
Mm-hmm.
it never leaves. It never leaves the next station once you're wet.
Mm-hmm.
It could be an hour cure time, doesn't matter.
Yeah.
Throw a heat curtain during that time. You could have 10 stations sitting out here at its expense, but it doesn't cost you time.
Right.
And it just keeps on.
Just like the recloud on the backside of the circuit board line.
But if you're doing it, trying to stay in line the whole way down, whatever your dwell time is how long you're going, right? So your Herbie is your cure time.
Right.
So you get your cure time down, it doesn't matter if it's 12 stations, then it becomes a second.
Sure.
Think, and you
Sure.
keep on, now your production expands.
Mm-hmm. Treat it more like a batch process at that point.
No, I think it's still a flow line. I think it's just an exit, that's all. And it's a flow line. If you find that you get better, then you just remove the station. And you only have 2 or 3 or 10. You start off with 10, and if you get better solution or better cures, then you can remove these stations and make the track smaller.
Okay.
No.
And what you see on the screen is the specs for that epoxy. I would be glad to find that I can do it quicker. I've not proven that.
100 kilowatts per square centimeter. That's not very high. And 240 to 365. There's a range there because it's a bulb from 240 to 365, as opposed to if that was a diode, you'd be like 395, 365. That's it. That's all you'd have to choose from. So they've got a range. They're saying less than 2 minutes, depending on thickness. Greater than 2 minutes, depending on thickness, and the thickness is like nothing. Single component, UV curable capsule.
And then, what to say about if you heat it, or how do you speed up the cure time?
Is there various cure schedules available for this material, or is it UV cure only?
I believe it's UV cure. I believe.
I just don't see anything here that says anything about a thermal schedule.
And
that's why it takes long to cure.
Yeah.
It's not clear. So it probably goes clear once it's cured.
Okay, Steve, I just sent you this document.
Okay, thank you. That's Epitech.
Yes.
How does it come? Is it in 25?
It's in cartridges.
Cartridges?
Yeah.
25
I'd have to look at the size, but yeah, it's cartridge probably 3/8 of an inch in diameter, about 3 inches, 2 inches.
50 mil. 50 mil cartridges. Yeah, I'm not going to use time and pressure. I think it's a little. Not saying we couldn't do it. It's just those little units that they have, they're molten plastic. So if you require a good deal of pressure to push them through, they accumulate pressure, and then it's very hard to get them to stop. And have you figured out the volumetric equivalent of your dispense shot size?
I did some calculations on that quite a while ago. I don't have that at my fingertips.
Okay. My dispense guys will ask for that. See if you can dig it out. Even if it's approximate.
Let me do this.
Time pressure. Syringe. Just air powered syringe. So cheap. Especially when you get a material that won't cure. Although sometimes if you put a UV material under shear, it will cure. Yep. Yeah, like if you run it through an auger and you don't turn it off in time and it just kind of grinds on it on the end, that amount of energy can cause it to cure, just like UV can.
Everything else is at that station. That's not there, it's not.
So how do you want to move this stuff around? We got walking beam. We got vacuum stations with robot placement. We got dial table. I don't think Precision Link is going to get us within half micron. I don't think steel belt can get us within half microns either.
We know people are soft. And Siemens is a big deal right now with how they're doing stuff, but I haven't seen anything that small.
Right. Hey, Lynn, after you do your mass calculation here, I see what you're doing.
Right there is your microliters.
0.0054, or I can't read it.
8.0084 microliters.
0.0084. All right, so it's under a tenth of a microliter. 0.0084 microliters. Okay. I'm surprised you have that good results with time pressure. You must have a really, really tiny needle on that thing.
It is a small needle. I don't remember the gauge right offhand, but yeah.
Yeah. Okay. So, can you bring up the image of your dial table again?
Sure. And give me just a minute, and I'll be right back.
Yep, no problem.
Hey, Steve.
Yes, Brian.
Are we fairly well along with the vision conversation? I kind of need to hop on.
Yep, you jump out. You go right ahead, no problem. I'll let Lynn know.
Okay, very good.
Okay.
Any other questions? Get in touch. Thanks.
We sure will. Thanks.
Yep. Bye-bye.
So is he selling?
I'm muted.
Okay, I'm back. Dial system.
So we should talk about timing.
I think you need two systems.
Lynn did too, by the way.
I don't, this is not successful with one system. You can probably make it with one system.
Mm-hmm.
The glitch will fall out of PM, and that's what they're expecting.
Mm-hmm.
I think you have a problem with one system. That's my opinion.
I think Lynn was telling me something very similar when I was out in Ohio. And in my mind, if you put all your eggs in one basket, there's a lot of things that can stop that machine.
We just have history with that. We've built significantly complex machines, told the customer right off the top of the bat, you need two. Our system was great. 5 years before it failed. Mm-hmm. When it failed, it was an emergency for the next system. And I get the two systems going, they've been on for 12 years, something like that, a ridiculous amount of time.
Mm-hmm.
But one's down PM, blah, 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 blah. They lose 2 or 3 days, no big deal. The machine's still running.
Right.
Then while you're there, you could PM that machine, so now you have machine.
Yep.
The one machine can be devastating to people that are expecting stuff work was critical.
Yeah.
It's not critical, and you could lose a week or two or whatever, because this will be a robust system.
Mm-hmm.
So building a robust system is part of the issue. You build enough, and they don't care if it's down for a month because you may have a part or a system or a laser or whatever goes down.
Yep.
If that doesn't mean anything, then fine, you stay with the one system for a period of time until you say, well, now production's getting to a point, or we can see the vision that production's going to pick up. Now duplicate the system. And by the way, here are the problems or the many issues that we're having. Now you have an upgraded system, probably costs less, but it's an upgraded system to what they're doing. And then you have the PMs on that too. So two schools of thought. It just depends on what the downtime means to them.
Mm-hmm.
You know, and especially from the get-go. And it's a lot easier and a lot more economical to build too out of the box. So, you know, there's a lot of schools of thought.
Yeah, once your proof of concepts have been demonstrated for, you know, what I call the, you know, the high risk process, then I think you could definitely go ahead and build system one. Once you're debugged, you can build a second system and debug it much quicker.
Yeah, I wouldn't do two.
Okay, but I would never build two at a
Not
time.
at the same time
No.
now. But you would
No.
schedule to build them pretty close together.
Yes, you'd want to get your materials in and your extra robots and, you know, those things as well. So.
Yeah. Yeah, the circle, I have that rectangle.
Nah, the circle of the index and dial, I like that. That's kind of cool. And
I
tools change.
do know that that can be highly repeatable.
Yeah.
When you have,
The dwell on them is just,
I mean, that's the best way to do it unless you still have to come outside with your cure time.
well, that's why you got the yellow stations on there. That's your cure time stations. You've got 4 stations in there in cure. And if you're 30 seconds a cycle, you've got 2 minutes of cure time sitting there.
Mm-hmm. And the transfer time can be very fast.
Yes.
Turbo driven.
At the 5 o'clock point, you've got, I would assume 5 o'clock is load, unload. And then
That is load, unload here. I have inspection here.
okay,
Now,
fair enough.
knowing that an index dial is never going to be perfect, I threw this together, but the more I think about it, probably the best way is to have slight movement in these stations so that it can lift and position from the bottom. And that way I'm positioning my wire exactly the same every time as opposed to my sensor, like I mentioned. It is so sensitive in position that I don't think we can do an index dial to keep it accurate enough just secured on
On the accuracy of the stage.
Well, we wouldn't do it with a cam driven station. We'd do it with a servo driven station, and every one of those positions would be encoded. I'd like to have this conversation with my controls engineer, and he's not with me, but you want to snap a picture of that, I can talk to him tonight and just ask him what he thinks. And then what about materials and coefficient of thermal expansion and those kinds of things? I mean, if that's a big aluminum disc, it's going to grow, it's going to shrink, you know.
It will. But you're in a clean room that should be environmentally controlled.
Yeah.
That should be stable. And if you're running 3 shifts, I'm assuming you've got AC running in there and heat. It should be climate.
You've got to test it out outside of the station. You're testing it here.
Well, yeah.
So you can't replicate what you're going to do there. So you have to have material that's not going to drift. You can still find out. You can use 7071 or something. You can use the aerospace aluminum as a hell of a lot better. You don't want to use anything else. Stainless, titanium, Invar, whatever. It's more stable. It's going to cost you an arm and a leg just for the stupid table. But you use the high-end aluminum. It's not going to move. No way. 7,000 series for aircraft aluminum? Not going to move.
Not going to move. It's already strain relieved and
Well, you got to,
aged.
depending on how big how thick you want to make it, but if you made it relatively thick, if you want something that's going to be thick and stable, it's not going to move. And if it moves tenths, it would be incredible.
Okay, good.
You agree?
Yeah.
I mean, I would go back to Jeffrey and say, hey, this is what we're thinking, and let him keep it. Yeah. As long as if with a lot of metal.
Biggest problem is getting the fixtures to repeat on the dial.
Mm-hmm.
I mean, physically mounting them.
You can do that with flags and servo, right? I mean, flags
But
and servo is what
the
the
problem is, it's location to location on that dial has to be repeatable within some number that we would calculate. Because as it goes station to station, your stations are fixed. Now, yeah, there's adjustments at the station, but your stations are fixed also within some point. And if you've got gross tolerances, it's not a big deal. At the super fine pitch tolerances that you're looking at, it gets interesting. The lift and locate there brings its own set of issues with it.
I would agree with that.
I like hard tooling.
Boy, do I love it.
Doesn't move, you know? And I can put vision into the pick and place, and then maybe we redesign the fixture so that those pieces aren't separate from each other. I don't know. Maybe the stage. Lynn, where are you loading the die? I'm missing that here. I'm sorry.
Yeah.
Okay, in this scenario, it's loaded from that wafer right there
I see it now.
to that
Okay.
fixture.
Yeah.
Now, I realize there's arguments pro-con on a dial. I know that the way it's concepted here, you got 10 fixtures, you're going to have variability in all these details. Not that you can't hold tight tolerances, but I'm a bit concerned. Now, here it's not nearly as concerning because I can use the vision to find it. Of course, I'm going to have some variability up and down, so I still got to be careful about that. The cleaning station, depending on what we do, would be great if we can do it right after the bond, so we wouldn't even have that station.
Okay.
But this is likely the most critical. Now, again, with end stations, you're going to have some variability. That's never going to be exactly there. When you got a wire that's 1/1000 in diameter and you're 24 inches from the center line plus, you're using this to get your final alignment, and I realize that. It's just there's a set of issues, and like you mentioned, even if we do a lift and locate, yeah, there's a set of issues there. That's basically what we're doing in the other concept is lifting and locating with a robot. But now, if we do a lift and locate, we could accurately locate it, especially here. That's most critical. Obviously, the wire here, we'd have to do that here. Vision, in order to get the right focus, you'd probably have to do it here. You wouldn't have to do it here probably because you just got light carrying.
Right.
So. But even, it will be in a controlled environment. But keep in mind, you go home for the weekend, you come in Monday morning, actually Sunday night here. But anyway, I don't want that to be an issue where it has to warm up for, 2 hours or whatever. But I'm sure there's ways we can work around that. So just kick it around. Keep that in mind.
Yeah, we should use vision for the critical locating as much as possible.
Mm-hmm.
I know I can put the dispenser on a small SCARA because if I'm within 6 micron of that position, it's not going to matter because the material will wick and flow and all those things. It's the die and it's the picking off the wafer that are obviously, the submicron accuracy here, which, that's die bonder world, right? So, Yeah.
And just, one of the ideas that I kicked around.
Granite block, and you just come over top. So your tooling's actually separate. I don't like that idea. This is your deck of cards, right? Your Vegas.
Just one other thing that I'd thrown together was if we had a racetrack and you brought them down through here, maybe precision link conveyor, whatever. You brought it through here and indexed it forward, shuttled it over, and brought it back.
Stellron. Stellron will do
Just another idea.
But they're not Still gonna have to swim. Still have to swim the part once you get in position. Take up less room than a dial.
I'm just not smart enough to see the cure stations and how they work in a circle. My brain doesn't work like that.
They'll go in there and they'll cure in the light and they'll
Sure.
come out.
Move back to the light.
I got that, but you gotta push them into line somehow, and I don't see that. I don't see how that.
Well, they'll just come under a window. Well, depending, they should come under a sealed window because the UV light, and like it'll swing in, and then when it's time to index, the light would retract, the part would move away. It'd be really bad if it didn't retract.
Well, what I would do is I would get the UV lamps and just basically make myself a, you know, an arc section where the ones they were going through, they're continuously exposed. I don't know how big those lamps are, but I'm picturing.
Here with your index time. Well, see, that's the other gotcha. And with this thing, you got to control your index time in this design because your part is hanging in the air. So if you have a rapid acceleration transfer with your control interval back up,
Yeah.
that mass, because I think it's unsupported, it's a cantilevered load right now because the wires are supporting the mass of the sensor.
Wires are supported.
Now, my thought on that is, as far as the wire hanging out, it is so short because we keep that as absolutely short as we can, and that is so light that I think you'd have to move that in a tremendous acceleration rate matter.
We do a spline curve move on that for accel and decel, but somebody would have to define what max.
Yeah, because you don't want the part
you
to, on index, because you want to minimize your index time.
Of
Because
course.
index time is like waste of money.
Yeah.
But you don't want to make it do one of these on you.
Right.
Because then everything goes to hell in a handbasket.
I think Schneeberger does a rotary cross roller.
Actually, they do.
Yeah.
Learned that for a while.
Yeah. You know it's going to be right. You buy it from Swiss.
I'll go get it.
Yeah.
And then we could just drive that from the center with a what do they call that? A torquer servo motor. I wouldn't put any gear reduction on it at all. I'd drive it right off the torquer, and we could get errors, following errors, everything completely fed back from one position. But I need the rotary underneath to support it all. It's got to be big. It's got to be big in diameter.
That's just a smaller one.
Yeah, no, that's the idea. Yeah.
They'll custom it.
I like cross rollers. Cross rollers are just as precise as you can get. Load them in any direction. Yeah.
Big hassle stiction. But once they're going, they're
Looking
Keep
over.
in mind,
I'll show you a big torque motor we can get. Yaskawa.
and it'd be great to size this down. Of course, I just threw this together on some of my experience, but
Yeah.
the epoxy dispense, if that could be smaller, of course, if this goes away and we can incorporate the cleaning here, this,
Epoxy dispense
configuration, I don't know what
as far
this
as I'm
is.
concerned.
Yeah, I don't know.
Yeah. Epoxy dispense would be on
And-
Ascara. It would
Okay.
be a very
And-
small stage, because it's not a big move. The only one that requires a big move is where we're coming off the wafer. The wafer's going to need more room than what you drew there, too.
Yeah. You have the frame on the, you got a 6-inch wafer, your frame is
Like
probably
this. Yeah.
10
Yeah.
inches if you're lucky.
Yep. I like the dial table. The more I think about
That's
it.
shown as a 48-inch, and of course, if we could minimize the amount of cure, and depending on the cycle time we actually get down to, obviously if we do faster than 30 seconds, then we have to take that into account too. But it'd be nice if we didn't have to have this number of stations.
What if I did a continuous line of UV curing? You know, I don't know how long those bulbs are, but imagine, you know, like a lighting designer creating you an arc of light that it stays underneath of the whole time, even while it's dwelling.
Yes, but you're probably not giving up, more than a second or second and a half on the index. It would help, but you're not gaining a lot.
not compared to the dwell time.
Okay.
But if you made your stations smaller,
Mm-hmm.
like all right, so right up the get-go, if your epoxy dispense is smaller, that's great.
Yeah.
So the next thing is dye picking place. If somehow.
And you could really do that offline and place this in here if you had to. Probably not ideal, but you could, do
Place the
that
block.
further away from the dial.
So you're saying you could pick into the block and then present the block?
Now, right now, we're moving this block around,
Right.
and that seems to work quite well. So yes, you could have two of these fixture blocks. So you load it further away from the dial, or further back, and then move that into position.
If you did that, you make your area smaller, so that way your workstations the pitch is tighter on your cord length, and that way you can reduce your dial diameter. You could do one of these. There's a number of different ways to handle that.
Yeah.
But if we pulled that in tighter, get rid of all that dead space and dead time, so that your station is tighter.
Mm-hmm. Pick distance is short.
But that's all with time and effort.
Yeah.
Working on the station. The package dial, the center dial, I don't think, you got to work out on the ancillary devices out there first to get them optimized before you can lock in on the dial. If you got your tooling, the tooling works for right now, so assume you deal with that.
You're not paying, you're not showing where you're paying off the long wire diameter here either, are you? In the,
It's
I see it now.
the feed
Okay.
spool's right there, and yeah,
I'm very
I'm winding
sure.
it up. Now, one thing we haven't talked about, but actually forgot about it, but if it's reasonable, I'd like a robot or whatever to unload and reload a new spool rather than the operator.
This robot that just basically pulls off a D10. Yeah, that's easy enough.
Put that in the middle.
You could. I wouldn't. I'd probably put it beside it.
So your last station needs to be an inspection station, and then you're going to have a packaging station?
How many times are we inspecting here? Just once at the,
I show one right here, but I really should do one after the cleaning station if it's incorporated here. I don't know if we have time that we can do it right here. I mean, we've already got a camera system here. Maybe we can just look at it right after we clean it.
we might be able to do the inspection under the optical laser too. Now, Rich just pointed that out.
This one here.
Yeah.
Except that if we replace that with either CO2 or plasma, and we can do it here while we have that secured,
Yeah.
that would be ideal.
Okay.
I don't know if we can take that much time.
Yeah. Well, could why that part isn't moving?
Well, I don't know why I wouldn't put the inspection station next, right after that.
It is, well,
When the next one's in there, it could be
but it
inspected.
adds another dial location to make the dial bigger as of today.
So you may
Right.
not have your dweller cubes
But
level out.
that laser cleaning station, that is the next one, has the capability of doing split field optics, so the camera can look where the laser's going to clean. So you can check it, that if you do it. Now, if you use a different process, I think you can still incorporate vision in either process.
I think so. You have some limitations because of the type of lighting you can use because the galvos are in the way. But if you can light up everything, externally, with off-axis lighting, you might be able to do it. Because off-axis lighting doesn't take up a lot of height. If it turns out that you really got to be up and over top, it's not going to work because you've got all your galvo head and everything else underneath.
But
so we'll have
thinking, but as far as inspection, thinking through this, I've already got a camera that I'm aligning this. What if I just
Right.
snap a picture after I'm done here, and then I snap a picture as well before I do my epoxy, because I got a camera here too.
Okay. You want Lynn to send this to you?
Sure.
What do you requested as a step file?
SolidWorks.
You want to work with it?
I can work with it in SolidWorks.
Okay. What version of SolidWorks do you have there, Lynn?
18th.
2018 is good. Okay. We're going to give you an email. See if you can send that over.
I don't know how
to
big this file is going to be.
Yeah, do you know how big it is? Can you put it on a drive or something? How big is this one?
I can put it on my Dropbox and I can just send you a link to it.
Okay.
Okay.
Perfect.
Do that.
My email is Barrett, B as in boy, IRETT, at efedwardfrankgroup.com.
Okay, back up. Okay, say that one more time.
Barrett, capital B-I-R-E-T-T, at efgroup.com.
Two T's there.
I think so.
All right, I got that. Okay. And I'm just going to send this as a blank email so you have my contact info.
Yeah, and he can fire it back to you.
Yeah.
Okay.
All right.
Little bit to digest here.
Now, do you want me to send you just this one?
I think so.
Yeah, that should
Okay.
be fine.
No problem. I'll make a pack and go, and I'll put it up there on my Dropbox.
Good way to go. And let me give you, I'll tell you what, send me the same link. I'll make sure Chris gets it. I think we might be 2017. I don't know if there's any compatibility issues. I'll check.
And this is Steve talking, right?
That's me, Steve, yeah.
Yeah, okay. All right.
Next steps.
Digestion.
Yeah, I agree.
Because before we start thinking about monies or anything like that, I need to make sure that we can do this and this makes sense for us.
And the concepts and where you build it and all that other good stuff. Okay.
It's manpower, it's how much time, because I can't absorb them for a full year.
Mm-hmm.
So there's other people that we have to get involved and make sure that we're in good shape. So there's, we've talked about this. We've already had conversations about this.
Right.
Now it's a matter of looking at the details and then saying, who do we assign, who can we get, how can we put this together, and does it make sense?
Utilization of resources and space and manpower, et cetera.
Because you can do $1 million job and make $30 on it.
You can lose money on it.
Yeah.
Trust me.
No, I don't know. I can tell you.
Yeah. And really, more than anything else, what we want to do is we want the customer to succeed.
Oh yeah. That's
That's the most important thing here.
It's number one.
We're all in agreement on that. Mike, I know you can hear me even though you're muted. Whatever problem you're having there, I think you can go ahead and stop the recording and send me a link to that later, and I'll make sure Chris has time to go through all these images as well. And then maybe as a next event, after your review and if you're still interested, we'll get Chris over here. He lives in Yardley. Okay, so we'll get Chris over here. We'll sit down. We'll do another discussion on this, and then in the meantime, I'm going to look at stages and those kinds of things just to see, if we start to populate a spreadsheet, all the hardware that we're talking